Welcome students to this video, part 1, where we will discuss and resolve some example of Lagrange multipliers. So the first question here we have is we need to use Lagrange multiplier method to find the maximum and minimum value for the function f of xy equal xy squared subject to the constraint x squared plus y squared equal to 1. So first thing first, I will call this constraint here, I'll just call it g of x comma y. So this is my constraint equal to 1. Now for Lagrange multiplier, what we need to do is we need to find derivative of f with respect to x, derivative of f with respect to y, and we need to add the constraint as is. So g of x equal to k. K in this example is equal to 1. Now, f of x should be equal to our Lagrange multiplier lambda times the derivative of g. Same thing for f of y equal lambda times gy. Now we have 3 equations. Let's write them down and then we can discuss them more. So the first one, if we do f of x, this is just giving me y squared equal lambda. If we do gx, it is only 2x here. This is equation number 1. Equation number 2 will be f of y, which is just 2xy equal lambda 2y. This is equation number 2. And finally, I have equation number 3, which is just we write the constraint as is. So x squared plus y squared equal to 1. And this is equation number 3. What we have so far, we have 3 variables. We have y, lambda, x, and I have 3 equations. So we need to find all the possible values for x, y, and lambda. After we find all those possible values, all of them without ignoring any possibilities, what we will do, we will write them down here in this table. So we will fill this table with all the possible values of x, y, and lambda. That satisfies the 3 equations that we have. Afterward, for each xy, we will find the value for the function f. So we'll have a table full of numbers. The maximum number in this table will be the maximum value for the function subject to this constraint, and the minimum value will be the minimum value for the function f of x, y subject to this constraint. So the maximum and minimum will appear after we fill up this table. And remember, we need to fill this table fully, completely with all possibilities. If we forget or ignore one possibility, maybe that possibility we ignore would be the maximum, maybe the minimum, and maybe it's not the maximum minimum, but we cannot make sure that we judge which one is the maximum and minimum without finding all the possibilities, without ignoring anything. Keep this in mind while we are solving these equations. So here we have 3 equations. Sometimes I have seen students in the past, what they do is they divide, I will just write this down here, divide equation 1 by equation 2. And the idea is to get rid of the lambda. If we just divide this by this, we might get rid of the lambda. Some students might just jump and cancel the y here. All these are not correct. Please do not divide. Never ever. If you divide, you might miss some of the values for lambda or x or y, which means your table at the end of the question will not be complete. So do not divide, please. So what we need to do is manipulation by equation 1, 2, 3. Take something from equation number 1, put it in equation 2, maybe 2, put it in a 3, and so on. Try to manipulate. So the best way I can see it to start is equation number 2. Because, first of all, I have 2 and 2, I can cancel them. Also, I have y and y, so I can take it as common factor. So from equation number 2, we have 2xy minus 2 lambda y will be equal to 0. So what I will do, I will take this one to the left side here. I will get this. Now take the common factor, so you get 2y x minus lambda equal to 0, which means, of course, I can now cancel the 2 easily, which means I'm end up with two possibilities. The first branch is either y equal to 0 or the possibility x equal to lambda. So I have two possibilities. I have to work them down separately. Each one will give me x and will give me lambda, and I will fill the table. This one will give me y and lambda and x. So I take all the possibilities if y equal to 0, all the possibilities if x equal to lambda. And that's how we will do it up here. So what I will do, I will start assuming y equal to 0, and I will substitute in these three equations what happened of y equal to 0. Of course, I use equation number 2, I will not use it. Now, let's put y equal to 0. Now, if you choose y equal to 0, the equation that will help me is the third one. Because it's if y equal to 0, I can easily find the value for x. That's what I will do it. So option or possibility number 1, y equal to 0. Okay, so what we get? We get from equation 3, we have x squared plus y squared equal to 1, which means x squared plus 0 squared equal to 1, which means x squared equal to 1, and that's give me only two possibilities, x equal to 1 or x equal negative 1. So I find x equal to 1 and x equal to negative 1. I have two values for this y, and once we have x, we have y. From equation number 1, we can get the lambda. So next is from equation number 1. Now, from equation number 1, we have y equal lambda 2x squared. Now, we know that y is equal to 0, so this is lambda. We know that the x is either plus 1 or negative 1. It doesn't matter because the left side is 0, which means lambda will be 0. So we get x equal to 1, x equal to negative 1. So what we have is the following picture. We have the value for y is 0, x is 1, lambda is 0. Same thing, value for y is 0, x is negative 1, lambda is 0. So if I go and fill my table up here, what I will end up with is lambda equal to 0, x is 1, 0, x is 1, y is 0. And for the same lambda, just let me write it down here in the middle. For the same lambda, I have x also negative 1, and y is always 0. And that will take care of the first row. What we will do next is we will fill this table, but yeah, we can fill it from now. Let me just fill it quickly now. If we substitute x equal to 1 and y equal to 0, what we will get up here is 0. Same thing if I substitute negative 1 and 0, I will get just 0. Which is, in this case, it is not maximum or minimum. Maybe maximum, maybe minimum, they are the same, so the value is 0. So what we need to do, we have to wait for the other possibilities. If the other possibilities, for example, 1, 3, and negative 1, we will assume this is the max and this is the min. And if all of them, for example, negative, then this will be the max because it is the highest one. So we have to wait until we finish this all. So that's what we do next is we have to go and search for the other values for number. We did y equal to 0. I think we did this part. So just let me click it up. We did this part. What we will do next is we will assume x equal to lambda. Now, if we put x equal to lambda, I think we could use equation 1 and equation 3. Let's see how we will do this. So here we have x equal to lambda. So what we get? Equation 1 will become y squared equal 2 lambda x, which means y squared equal to 2. Instead of lambda, I will write x. So x with x, I will get x squared. So I get this one. And from equation number 3, this is equation number 1. And from equation number 3 now, if we substitute, we get x squared plus y squared equal to 1. This means x squared plus 2x squared equal to 1. This gives me 3x squared equal to 1. This means x squared equal 1 over 3. Now, remember, I don't need x squared. What I really need is the square root of x. So this will give me two options. Either I will get 1 over square root of 3. The second option is the negative 1 over square root of 3. So by this, I find two possibilities for x. Now, each one of them will give me values for y, values for lambda. Of course, values for lambda is straightforward because remember, lambda is exactly the same as x. So it will be the same here. Now, whatever is missing is I need to find the value for y. Now, from where we get the value for y, I think from this equation would be a good starting point. If you know x, let's see how much y squared will be. So here, y squared equal 2x squared. So y squared equal 2. Now, what is x squared? It is 1 over 3. So this means y squared equal 2 over 3. So again, we will have two values for the y. It is either square root of 2 over 3 or y will be negative 2 over 3. And that's the answer we have. We have two values, x 1 over 3, lambda 1 over 3, and then we have two possibilities for the y. Let me go here and write them down. So here we have x, lambda is 1 over square root of 3. We get two answers. 2 over 3. And the second one is negative 2 over 3. Now, each one of them will give me values for the f. I will do it in a minute. Let me just now go and finish all the other possibilities because I didn't finish all the branches. We started here. We finished from this one. And now let's do this one. So if we do this one, we'll do it the same way. We have y squared equal 2x squared. This means y squared equal 2. X squared is again 1 over 3. So we have y squared equal 2 over 3. Again, we get the same two answers, 2 over 3. Y equal negative 2 over 3. Now, we have to take this x, this y, and then we have to take this x, this y. Don't mix them up. I can see in the past some students take only the positive, positive, negative, negative. That's not correct. There are 4 different possibilities, not just 2. So here you have to write them down as we go along. Of course, here is negative 1 over square root of 3. This one will be negative 1 over square root of 3, negative 2 over 3. And this one, negative 1 over square root of 3, negative 2 over 3. And now the final step is we only need to evaluate those numbers, and then we will check who's the maximum of all will be the maximum value. So if you want, I can just say, write it down here, the maximum value equal, comma, minimum value equal. Now if we substitute here, x is this one, y is this one. I think the first one, what we will get from the first one is 2 over 3 square root of 3. Now the second one, I think will be the same because there is a, and for this one will be negative 2, 3 square root of 3. And that's what we get. Now, if we compare which one is the maximum, here we have two maximum value, doesn't matter for us. I can choose any one of them, they are the same. So this is the max, and of course, this could be the minimum. So the maximum value for this function, according to this condition, is 2, 3 square root of 3, and this negative 2, 3 square root of 3.